Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the camera tracker node. So we're going to jump into Fusion where we've got some footage, and we're going to assume we need to put some type of 3D element in this footage. And that's exactly what the camera tracker node is for. It's kind of our link between 2D live footage and the 3D world. So what the camera tracker node is going to do, it's going to track our footage and create a 3D environment for us to use in 3D software or within Fusion. I'm going to go ahead and bring in a tracker node, a camera tracker node, and add that. Now, I'm going to break this down into 3 videos as well, because it's going to get extremely long if I do everything with this camera tracker in one day. So today, I'm just going to be going over all the settings, almost all the settings within the camera tracker node, so you can get up and running and know what you're doing and start playing with it. Tomorrow, we will rebuild this scene the way it should be built before we use this camera tracker node, and that includes doing things like lens distort and noise reduction and everything. And then we'll go back over the camera node and get a really good track on this footage. And then day 3, we'll use that and we will create something pretty simple within the 3D world. I know I haven't gone over 3D info yet, but we'll use this node to create something simple in a 3D world. So jumping in, camera tracker has 4 inputs / outputs. Our orange triangle, as we know, is our media input. So we're going to go ahead and input our media. We have our image output, which goes to our media out. Down here, this output is for your scene output. And this is what we will input into a 3D environment within Fusion to be able to see all these locations, and we'll be able to build a scene off this. This up top is for your occlusion. And speaking of occlusion, yesterday, I believe it was yesterday, we went over the planar tracker and I talked about this within that occlusion. Well, apparently that node no longer allows you to use just regular alphas as masks or anything. It has to be an actual shape, meaning we have to use a B-spline or an ellipse or something with a shape. And on top of that, it has to be a clean shape. Meaning if our footage, we wanted to create occlusions in it to get her movement out, we could create one occlusion on her. And say there was somebody walking in the background, we wanted to do another occlusion on. So we brought a second one in and we did an occlusion on somebody in the background. Now you would think normally in most nodes, we can combine these two with say a merge node or a multi-merge. But you can't bring this into the occlusion. It doesn't accept this node. It has to be a clean shape. So if you have multiple things you need to occlude in your footage for your camera tracker, your best bet is to just use your multi-poly. That way you can build multiple polygons, because this node we can input, and it doesn't matter how many polygons you have in here. So you'll be able to create your polygons and do your occlusion. So speaking of, let's go ahead and do our occlusion on this footage. So what you want to occlude is anything that is moving. And she's not moving much, but she is moving. And additionally, we have this weird moire or whatever, I can never pronounce it, moiring going on with her pants. So you can see they're flashing. So that could cause issues with our track as well. And like I said, if you had a bird flying in the background, you'd want to track that out. Or we do have over here, we've got some reflections going on in the window that are moving at a different pace because they're reflections that could throw our track off. But I'm going to use that later in this node so we can show you how to do some corrections. So we're just going to go ahead and create a little mask, a quick one, around our actress here. And it doesn't have to be perfect. We're just masking her out. So there we go. And we're going to make sure we animate this. So if you remember right, anytime we want to animate this, we just have to make sure we click on this right click here for shape animation. And we can go to our last frame. And can bring these in. And again, it doesn't have to be perfect. It's just got to keep her movement out. That's the only purpose of this little mask. So let's make sure that keeps her out, and that's good. So that is our occlusion. So on to the tracker node. Now on our tracker node itself, we've got this auto track and reset. And what this auto track is going to do is it's just going to do a quick track and see what's going on in the footage and give you some trackers. So if I hit auto track, it's going to auto track through, and you can see we've got some little points coming up, and you can see they're also inside our mask. So we need to go to our mask and make sure we hit invert. So now our track points will be outside. So let's go back to our tracker, reset that, and hit auto track. Now we've got some points outside being tracked. And you can select this preview auto track locations, and theoretically, before you even hit auto track, if I reset this, you should be able to see all these points, but sometimes it gets glitchy and the points disappear and you can't quite do much with it sometimes. So I like to just go ahead and hit my auto track so I can see what's going on and get some points going. And again, if you need to reset it, you just hit reset button. Now, mind you, this isn't your actual camera track or your camera solve. This is just kind of finding those points for you so you can do your camera solve. So before we move to that, right down here we have detection threshold. And what detection threshold does is it'll determine the sensitivity of the features that are being detected. So by sliding this left and right, we are increasing the amount of features it's detecting. By sliding to the right, we're decreasing the amount of features. I'm going to go ahead and leave this here for right now because our next one is minimum feature separation. And what minimum feature separation does is it determines the spacing between the auto-generated tracking points that we can see. So decreasing it will decrease the separation distance. Increasing it will increase it. So if I go ahead and decrease this so we have more points, then I can start playing with my detection threshold to increase it or decrease it. Now, mind you, all these are going to increase or decrease the speed of your solve. So if you don't have a fairly beefy computer and you have settings like this with a bunch of points, your solve is going to be fairly slow. Now down here we have track channel, what channels we want to use to track those points with the red, green, blue, and Luma. And again, it just depends on your footage, which you want to select. I'm going to leave it on Luma. Your track range is the range of your footage that it's going to track. And by default, it's set to render, which means the render duration is the timeline itself. If I go to global, it's going to be the full duration of the timeline. If I use valid, it's going to be the duration of the source media. And custom, I can select my time under the custom. So I'm just going to leave this under render. Or bidirectional tracking checkbox. What this will do is if we select it, when we track forward, it's going to track backwards when it's done, but it's not going to add any additional points. What it's going to do is it's going to track your points that were created on your first track. It's going to track that direction again to give you a reverse direction. So that'll help your final solve in the end. Now our gutter size, what our gutter size is doing, let me find one with a bunch of points, and you can see how your points are a little finicky. Your gutter is the area around your footage, and you're setting the size of where these tracks need to stop tracking so it doesn't interfere with your solve. So by default, it's set to 1. And if I set this to 0.5 and go ahead and hit my auto track, and you notice it just tracked in reverse too, it's giving us points closer to the edge of our footage. So if you need to increase those points near the borders of your footage, this is what you use, your gutter size. Now your new track defaults. Under here we have our tracker type. And by default it's using optical flow, and optical flow is great, which is what I use 99% of the time. But if we have footage that would say you had a bunch of cross traffic or things going in multiple directions around, you may have to use Fusion Tracker. And if you use Fusion Tracker, you've got options for your pattern size, close tracks when track errors, so you can change your margin of error, and your solve weight. And any time you see this solve weight within this node, I would just leave it at its default setting, because it really starts changing how your solve and how your camera interacts once we start changing this solve weight. And if you have extremely simple footage to track, you can go ahead and use the planar tracker. And under the planar tracker, we have our pattern size, our pattern type, if you remember from yesterday, our transform on our X and Y, or X and Y with rotation, X and Y with rotation and shear, affine, and perspective. But I'm going to leave this on optical flow. And I'm going to leave all these settings on their default. And primarily because we can improve this in our solve. Your auto track defaults, all this is you can name your track prefix. So if you have multiple camera solves going around, you could say like shot 1. You can change the color. Now, if you change your color, you need to make sure you go to your options, and under your colors, you have to select user assigned. So your colors won't change unless you use user assigned. So with these settings, I'm going to go ahead and reset back up and get my auto track. So we've got a bunch of points auto tracked. Our next option up here is our camera. Now, if we know our camera length, this is where you would input it. So if you know what lens you use, you know what film you used or what camera you used, this is where you input that stuff. And if you don't know this, your best bet is to leave it just at its default settings, because it's going to figure out all this stuff on its own based off this setting. So once you start playing with your focal length and trying to guess what it is, it could throw a lot of solves off. And same with your film gate. You can guess, like I can guarantee with this moiring going on, this is not an Ursa. So, because that doesn't happen. So I could tell you it's not an Alexa. It could be a pocket camera. It is not a broadcast, Ursa broadcast, or a 4.6 or a 4 or an EOS. And it is not a red. Could be a Sony. But my guess is this is just a standard DSLR like a Luminix or something like that. So this is why we're getting that weird wiring going on. So if you know it, go ahead and set it. If you don't, leave it at default. Now on to our camera solve. So before I jump in here, I'm going to go ahead and just solve this real quick, and we're going to go over everything afterwards. So I'm going to select my solve button. And what this is doing is it's solving all those points that we auto tracked in the beginning to solve for that camera. So that's what this solve button does. So clicking this solves for the camera. And if you need to delete that solve, you can delete it. But you can make corrections to it and resolve without having to delete. Speaking of solve, this is your solve summary right here. And the most important part is right here. You have your average solve error. And basically you're shooting for anything below 1. And our initial solve gave us a solve error of 0.6382, which isn't bad, but I personally shoot for anything below 0.3 on standard footage. If it's really imperative, I will shoot for 0.1. So an average solve error initially of 0.6382 is not that bad. So in order to get this solve error lower, we've got multiple options down here. So first off, we have solve options, and up top we have clean tracks by filter and clean foreground tracks. And what these are going to do is they're going to allow you to click this button. It's going to clean based off your settings. Same with clean foreground tracks. If you clean your foreground tracks, which is cleaning fast moving objects or fast moving tracks. So if we have any super fast moving tracks in here that we don't agree with, in this shot we really don't have anything, but say there was a chair up front of the camera moving a lot faster, we can select all those tracks on that chair and clean those foregrounds because it may throw off your camera track. And to be able to make these selections and clean them and delete them, we can auto select delete tracks by filter and delete foreground tracks. So once we make any corrections and we click this, it'll remove those tracks. Now down here we have foreground threshold. So what this slider is going to do is going to detect your threshold for finding the tracks on those fast moving objects. So basically the higher the value, the more forgiving it is on them. So if we had that chair there and we needed that track in there, we would raise it to make it a little more forgiving for that chair, or lower it if we don't want that in there. So I'm going to leave that. For accept solve error, what this slider is going to do is it's going to set your maximum threshold for your solve error. So basically, if the solve error is greater than the value you set, the camera tracker is going to pretty much sweep the focal length setting in an attempt to bring the solve error under that acceptable value. And just as a reminder, if the solver can't find a solution, the tracker is going to display a message in the console that the solver failed. So if a solution can't be found, you pretty much need to try to input the correct focal length and all that stuff. And that's why I say playing with this camera data sometimes upsets that solve. So I'm actually going to drop this to 2. Now our track filtering, this is where we're really going to start helping our solve error. So our minimum track length is pretty much setting how many frames that each of these need to be tracked to be considered a good track. So if we go to our options here and we hit our trail length, we can increase our trail length and you can see the length of our tracks. So as we play through, you can see they're longer or shorter. And that's what that trail length will do. So let's go back to solve and let's increase our trail length. So let's say we want a minimum of 10 frames for that solve to be good. So if we look down here under selected tracks, making that one change just selected 203 tracks of our 1237 tracks that we originally had, meaning 203 tracks no longer fall within our correct solve based off our new selection. So what I'm going to do is I'm going to keep resolving every time I make each of these changes. And normally what I would do is I would make all my changes and delete everything I know I want to delete and then resolve again just for a second time, and I would be pretty much done. But I want to show you how each of these settings are minimizing our solve error. So our selected tracks, we had 203, as I said. These are our operations on our selected tracks. So of those 203 tracks that are now selected, we can delete them. And you have the option to delete, the option to trim previous. So if I was, say, in the middle of the track and I wanted to delete all the track data from previous tracks, I would select that. If I wanted to trim all the ones following that to the end, I would select trim next. I can also rename my tracks if I need to rename, and I could set colors if I need to set color. And I will cover the rest of these export flags and everything here in a second. But what I want to do is I want to delete these 203 tracks that were selected by changing our track length. So I'm going to select delete, and now they're gone. So let's go ahead and solve. And we just dropped our average solve error to 0.3534. So down here we have maximum track error and maximum solve error. And what your maximum track error is doing is it's going to select tracks that have an average track error greater than the slider's value. So basically when it tracks, they're automatically being terminated when their track error exceeds a certain threshold. And this lets you readjust that threshold. And I'm going to go ahead and leave it at 0.15 because that's not that bad of a threshold, because our main one that's really going to drop our error is the maximum solve error. And you can see it's set to 2.5, which is pretty high. So if I go ahead and set this to say 1, which I said we always want something higher than 1, you can see that just selected 32 tracks. But if I say drop this to 0.3, what we're really shooting for, that just dropped selected 226 tracks. So let's say 0.2, and that just selected 500 tracks, so it's just too many. So I'm going to leave this at 0.3, and I'm going to delete those tracks. And let's go ahead and solve. And our solve error just dropped to 0.2066, which is really good. So we can kind of get even better if we really wanted to, but looking at these tracks, I'm not seeing anything really stick out. And I see a couple that don't help us, but nothing major. So let's say these tracks up here on the ceiling were really bad tracks. And one way to see that is down here we have show names. So if I show all the names, this is actually showing all the names of the tracks. Remember up here on our track page where we changed our prefix, this is where the prefixes show up. And if I want to see my frame range that each track is on, I can show those. So it's showing how many frames each of those tracks are going for. Shut those off. And then I can also see my solve error. So if I select all, I can actually look at my solve errors of each individual track. So as I go through, I can look for tracks that are fairly high. Like this one on the ceiling is sitting at 0.31, so that's fairly high. So if I wanted to, I could select this track. And you can see we have one track. I could come up here and just hit delete. So it's gone. Additionally, we have this other one that's at 0.321. Say I selected that. So I can go ahead and delete that as well. And once I deleted those two, we can go ahead and hit our solve again and see if that drops us. And it just dropped us a little bit. So you can see how getting in there finagling all these tracks are really going to get you a good track. So let me turn this off. Now down here, we just have our selected tools. We're showing we just selected 7 tracks. If we want to clear that, that just unselected them all. So we can invert it. So it's going to select. Let me go ahead and clear that. If I select this one, but I want to see all the rest of the tracks, I can invert it. So it just selected all the other tracks. And if I just want to hit visible, what's visible, because you can see each frame we're selecting different tracks. So it's going to change to what's visible. If I want to select all of them, I can select all, and I can search if I want to search for a specific subframe or a name. And under our options tab, we have the, I already covered the trail length here. Our locator size, we can change our locator size if we want. And your track colors, your locator colors, and your export colors you can change. Remember, you have to have it on user assigned if you want to assign your own. We can make our image darker so you can see your tracks better. And it's not going to affect your actual image. It's just making it on this node darker so you can see your tracks. And we can toggle on and off our track markers, our projected locators, turn on and off our trails. We can turn our patterns on so we can see what those track patterns were. And tool tips, we can hide and close. And right here, this is where you would change your colors. And right here, you can select how you want your reporting done, whether you want it on your track or on your actual solve. So tomorrow, we will get into actually doing a real track on this, and we'll do some problem stuff. I'm not going to solve it quite as fast as I did, so we get some problems in the back. And we're going to go over exporting. So I will see you in the next node breakdown.